Yeah, so IC specifications, right? IC specification. We have seen that there are certain specifications which has to be provided by the manufacturers in order to provide information to the to the end user. So which are those specifications? First, delay, time delay, then power dissipation. We have seen that that is okay. You should note that that is a static power dissipation. We have seen that the power dissipation can be a product of that the power which is drawn from the main power supply and the current which is available for logic 0 and logic 1. After that, we have seen the voltage parameters, the current parameters, then the figure of merit of any IC, then temperature, then that's it. Alright, so let's begin. Today we are going to see what are called as programmable logic devices. Or PLDs, you can say. See this, as I said, as the circuit grows, okay, the complexity increases. I mean, you are facing difficulty while making up circuit with 3 flip-flops, 4 flip-flops, and outputs wasn't coming. Imagine that you have to design a big circuitry with all the control information, data information, and so on. If the IC configuration, like, see, what is the practice? There are some standard gates which are already available in the market, like NAND, NOR, and so on. And we are using those NAND gates, NOR gates, and input NAND gate, NOR gate to implement our specific logic. But it may happen that we may require something which is too complicated if we go for this NAND, NOR implementation and so on. That's why we go for the logic devices which are actually application specific, you can say. So these logic devices can be programmed by the end user according to his or her requirement. So these programmable logic devices are classified into these categories. First, I'll call as ROMs. These ROMs are the same which you are having in your in your computers, any digital computer, mobile phones, and so on. Then comes PALs, programmable array logics. And third comes PLAs, programmable logic arrays. See, these names, I mean, just they have interchanged this logic to array. I mean, see, this name has evolved with time. Actually, this PAL was a proprietary word for monolithic semiconductor. I mean, this was a company, Monolithic Memories, and this term was coined by them. Then has come PLAs, which are actually more configurable as compared to PLs. These are called as programmable. We should be very careful with using these names, programmable logic arrays. Called as PLAs. Well, let's see all of them, okay, one by one. These ROMs, as I said, how are these categorized? What this, how do they differ in the programming? So these ROMs, I'll just make a quick comparison. See, as we have seen that any Boolean expression can be expressed, any logic function can be expressed in min-term form or in max-term form. In min-term form, we have a simple configuration of AND at the first in the first phase and the OR gates in the next phase. So according to that, these programmable logic devices are defined. So if it's ROM, so we have what you called AND and OR. So these are the stages, AND stage and OR stages. In this, if we have ROMs, we have this fixed. and this programmable. For PALs, we have AND gates as programmable. And this is fixed. And for PLAs, we have both of them programmable. Alright, this is how these PLDs are classified. Let's see them one by one. How the ROM looks like. So we have seen. Okay, let me write first. ROM. These ROMs are read-only memories. These read-only memories, as the name suggests, we can, once they are configured, you can't change the data. Okay. So there are various types of ROMs which are available. So the categories are simple ROM. This is what is called as PROM or programmable ROM. So in ROM, it's like, it's here you can't change anything. I mean, if once manufactured, manufacturer will provide all the information, and once it is fixed, you can't change. In programmable ROM, manufacturer will actually give one-time programmable capability of that ROM. Okay, they will provide memory which is one-time programmable, which user can program. Once it is programmed, you can't change. Then we have what is called as EPROM. This is called as programmable ROM. This is called as erasable and programmable ROM. That means we can write it, more time, not once. I mean, we can write this ROM multiple times. Okay, we can configure it. And usually this writing procedure is done using programming. Okay, and this programming, what it does is, it will simply blow the switches, and we'll see that the switches or the fuses which are available in nickel chromium, what is called the nichrome fuses. Through programming, we can change those, or you can configure those fuses. Then we have what is called as electrically erasable PROM or EEPROM. See, here the erasing of data is done using exposure to UV light. So they actually expose for some hours the IC, they expose it to UV light, and the complete data is erased. That is how the erasing happens here. Here we have electrical erasing capability. Alright. So general structure of ROM looks like this. What we have is decoder. So it's like N is to K decoder, you can say, or I'll simply write a decoder. You see, and here it is like programmable OR gates followed by OR array. This is ROM. ROM is simply a decoder with OR arrays. Let's see. ROM, these decoders we have already seen. How this decoder look like? These decoders have, let's say we have 2:4 decoder. What do we have? Let's say 2:4. How the decoder looks like? Tell me. Remember this? Now here it's all fixed. I mean the AND. Have you seen this structure? We have seen this. जब इसके ऊपर वेरिलॉग का प्रोग्राम भी हमने किया हुआ है 2:4 डिकोडर पे, इफ यू रिमेंबर. Let's say I have two inputs A, B. What I have with me is these AND gates. And how many AND gates are required in decoder? You tell me. 2:4. How many AND gates? 2 inputs and 4 outputs, right? So 4 AND gates. We have seen this. I'm drawing single line. This is like a bus, I mean a vector of wires. So here the specialty of this is like all of these are like fixed connections. Like you have seen the decoder, right? Depending on what we give as an input 0001, 1011, only one of these lines are active, isn't it? We have seen that. So that can be shown like using this. So these are like fixed links. 0001. At a time only one link will be active, right? So what does this mean? I mean only single line. This is like a this is the, and it has bus, I mean which has connections with this and this. I mean two lines are taken out, okay, which is connected to A bar and B bar. There are two lines. Similarly here, and these are the decoders, right? This is what we call as a decoders. 2:4 decoder. And in addition to this, what we have is OR gates. Now these OR gates are programmable. That means so in this we may have, can you tell me what array it would look like? I mean this is like, if these are the address lines are like K, if K address lines are there, or you can see it as a decoder K address lines, okay, K address lines. How many lines would be at the output? 2 to the power K, and is to the outputs, let's say it is P. So this is like a 2 to the power K is to P wrong, okay. So as I said, these OR are programmable. See, I am indicating the programming, the indication. See, this circles indicates fixed nature of the connections. If it is programmable, there are some fuses which are available. Let's say now I am indicating that with this one. So this is like a fusible link. And this is what is called as a fixed connection. Alright. Now I may have you know connections like anything. I mean, these are all programmable. Now see, what does mean? What does this mean? A3, A2, A1, A0. See here, this ROM is something used as a like read-only memory. That means the manufacturers ये read-only memory ROMs किस लिए यूज़ की जाते हैं? जैसे for example कंप्यूटर मैंने बूट किया, उसको कुछ पता ही नहीं है. I mean it has some BIOS information रहती है, या फिर ऐसा भी हो सकता है कि let's say I want to display some sine wave or anything like if I want to save some as a table or a lookup table, something like some information which has to be provided on the boot of the system and so on. So for such purposes these ROMs are used. So it has some fixed amount of information which is available in this, depending on what is the size of that IC. So here, what is the capability of this? Say for example, I need to retrieve an information which is available here. So what I will say is, when this line is activated, you tell me the first one. So I will write this as B, B3, B2, B1, B0, and let this be A0, A1, A2, A2. When this link is activated, you tell me. When both of them are 0, 0, that means at 0, 0 location, what is the information present? Now, when it is 0, 0, which line will be active? This line is active. That means here it is 1, and rest of them are 0. Is that okay? This is what is a decoder, right? One line will be active and others will be deactivated. If this was 1, okay. What is? Can you tell me the information which is retrieved at this address? So at A0, what is the information retrieved? Yeah, 10, 10, isn't it? This is fusible link. So it is 1010. That means if I need to retrieve any information which is placed at location 0, 0, I need to give 0, 0 here at A and B, and accordingly that will be retrieved in this B3, B2, B1 and B0. Okay. Similarly, you tell me the, if A1, yes, and so on. Now see, what does indicate? A single line indicates multi-input OR gate. Here single line indicates multi-input AND gate. Okay. So if I am making connection, that means this indicates A bar and B bar. So this one, this line indicates A bar and B bar and B bar. Okay, this whole is indicated by using these multiple lines. I mean, just for simplicity purpose, otherwise I may draw multiple lines. I mean, that doesn't mean anything. So when A and B are 0, this will be 1, right? When A and B both are 0, this will be 1 and rest of them will be 0. Hence, only this line will be active. So A1, what is the information you tell me? 0, 0, 1, 1. This A2, A3, tell me. And so on. So you may have any number of output lines here. I mean, you may have any number of the bit length or the word length. You can have anything. Okay. So this is what is called as a ROM, basic structure of ROM. You can implement any logic, any Boolean expression in ROM, isn't it? I mean, I may specify any expression and you can accordingly program and save it in a this is like a lookup table, right? So this is like something we are saving it and we are retrieving it by giving some address lines. So these are forming the address lines. Is that okay? So actually, how these connections are made. In fact, I'll just say Now this is all about ROM. What about PLs? As I said, the AND gates are programmable, but the OR gates are fixed. Now see, these are like, I mean, why it is like that? I mean, why didn't people directly jump to PLAs, programmable logic arrays? It's like, you know, it has evolved with history. Okay. Firstly, they were very satisfied with those fixed arrays, NAND and NOR gates. Then they were able to make those AND gates configurable, then OR gates configurable, and then they have landed up in making both of them configurable. So these AND gates are, say for example, if there is multiple input AND gate, let's say 3 input, or an input, you can say. What they have is actually some kind of fuses like this. This is a symbol for fuse. So when they are intact, okay, they are connected, right? And through programming, what happens is, we are writing them, we are blowing these fuses. So these fuses are usually from nichrome material, okay. Nichrome is nothing but an alloy of nickel and chromium. So these fuses are actually blown up. That means if I am blowing this, link, that means it has no concern with this input, and so on. In that way we can program the AND arrays, and similarly the OR arrays. Okay. So the structure for the PLAs and PLs would be same. Just, you know, if I place this, you know, cross, I will say that it is programmable. If I place it like a, you know, dot there, I will say it as a fixed, and so on. Okay. So these are all about logic devices, programmable logic devices. All right. So I think this was the topic which I wanted to take last, and yeah, you should be able to design, okay, any Boolean expression or any logic function using any of these PLDs. If I ask you to design, let's say for example, if I want you to express some Boolean function a, b, c bar, or a, b, some expression, okay, should be able to implement this using all three of them. Okay. How will you implement this? Using ROM. Say for example, you will simply take the connections from a bar and c bar. Now see, you can't change anything here, ROM. So you'll have to, you know, go to the line where, what is the address of that line? You tell me. 010. 010 you have to specify. Okay, that line and uska jo AND gate hai, okay, you have to, you know, make a cross on that line. Okay, for 2 and just let me restrict it to this one. A bar B or AB. So how this can be implemented? Just go here, A bar B, that means 0 1, right? So this is 0 0 1, this line, okay, this line is active. In that I want, and also I want what? AB, right? So I want here, I mean rest of them will not be connected. This one, and what do I want? AB. Where is AB? ये वाला है ना? I'll make these two connections. और ये multi input OR gate तो है ही. तो मतलब what does this indicate? Yeah, OR configuration. Now see, you must take care that, you know, how to address this, because at a time only one will be active. Okay, so that has to be taken care of. See, it's very easy to implement the logic using PLs or PLAs, but here it's like, you know, have to think how these logics can be implemented, and that I give you as a homework to design Boolean expressions using ROMs, Boolean expression using PLAs and PLs. Sorry. So homework is using ROM, PALs and PLLs. Alright, fine. So this is what I wanted to cover, and there are some miscellaneous topics which you should look on. I again give you as a homework. So some topics which are left are what are called as hazards. Hazards are of two types: static 1, static 0. I may ask question, again I am giving homework, I may ask, I may not, okay, questions based on this. Next topic can show over controller design. This is actually a part of the syllabus. Many things which are not part of the syllabus we have taken, like TTS, EMO, these were not part of the syllabus, but those were important and I have covered. I put more emphasis on programming. I mean, it was intended for 2-3 lectures, for 4 lectures I have taken more. So you have to cover this controller design part. So the controller design is all about, say for example, you want to design an ALU, and you need to control at what time, at what address this this operation should be controlled. Like say for example, I need to design a multiplier. I need some control signals. Just a minute. Hello. आप अभी ठीक है निकल रहा हूँ, 10 मिनट लगेंगे मेरे को, ठीक है। In controller design, say for example, you need to design a multiplier, when you need to load the data, when you need to shift the data, and so on. So this control signals has to be provided. So that controller design part, again I am leaving it to you. And the topic, okay, you can look for what is called as a dominating rows and columns, the concept of this in Quine-McCluskey method. So there are some miscellaneous topics also left. Just scan the syllabus and you'll come to know. Alright. So any problem till now? See, I'll just tell you in short. So I'll stop here. I need to go.